As you said, my name is Camden Palvino. I'm a transportation engineer with DVRPC, and I'm going to take you through our US 202 Section 100 operations analysis. So being the first of three speakers on DVRPC, like the onus falls on me to kind of tell you who we are and what we do. We're the metropolitan planning organization for the Philadelphia region, so 9 counties, 2 states, 5.7 million people. It's the 7th largest metro area by population in the nation, consisting of over 350 municipalities. And as an MPO, we do TIP, so Transportation Improvement Program, LRP, the Long Range Plan, and work program activities. And this is one such of those activities is this study. So looking at the study here, we see 202 in black, kind of proceeding around the periphery of Philadelphia. It connects the 4 suburban Pennsylvania counties in the region. It also, Section 100 specifically, which is further south, serves as a vital link to Delaware, but also as a local arterial within Chester County. And Chester County itself is the fastest growing county in southeastern Pennsylvania, projected to increase population employment 28.4% between 2015 and 2045. So a lot of the growth is going to fall on US 202. Like, in fact, if I'm heading up home from Wilmington to Northwest Philadelphia, I'll be routed on US 202 as opposed to I-95. So it just kind of shows that this road does see a lot of through traffic. It's not just a local highway. So born out of this growth and this projected demand, both PennDOT, along with CCPC, the Chester County Planning Commission, and also the townships approached us and really wanted us to take a look at some points along the roadway that are bottlenecks or problematic areas, and basically just have us make recommendations to improve operational efficiency along the corridor. And we'll find that operational efficiency kind of depends on who you ask. Obviously, PennDOT has a different priority than maybe the county or the townships in terms of where we're giving time, and our priority in terms of the traffic flow from road to road. So our study area is from Skiles Boulevard down here in the south, up north through Matlack Street, that intersection. And then there's also, so Skiles and Matlack are signalized intersections, and there's also a signalized intersection right here at the Parkway Shopping Center as you get off US 202. And then here is just our VISIM model that we built for this project, so there's not a huge study area. Then also taking a look at the study area, besides modeling, a lot of our countermeasure analysis has to do with safety and crash reports. So looking at the crashes for each intersection, we see the furthest north intersection, US 202 and Matlack Street. We saw 55 total crashes from 2012 through 2017 with 1 fatal injury. On the US 202 southbound ramp, 10 total crashes with 1 serious injury. One thing to note is that there's a lot of hit fixed object crashes here and also a decent amount of crashes at night. So that could speak to either poor guidance in terms of lane departure or lighting, but also you see the serious injury was down here at the merge, so there could be some issues that we can look at in the merge and safety-wise there. And then on the 202 northbound ramp, 20 total crashes in that area with 1 fatal injury. This could be a bit skewed in that, like, it wasn't really on the northbound ramp, it was at this intersection a bit further upstream of it, but this was definitely a consideration in our alternatives. And then finally, the further south, signalized intersection at Skiles Boulevard, 27 total crashes, none of them fatal or serious. So as the corridor, the majority of these crashes were rear end crashes, 52%, followed by angle crashes. We saw 188 total crashes, 26% of which occurred in 2017, which represents a gradual increase over the 6-year period. We saw 2 fatalities over this period, the study period, in this corridor. And then 9 crashes on the southbound ramp or near this merge with southbound US 202, which we kind of keyed in as an area that could be improved with any sort of operational recommendations. But the crashes didn't tell the full story, and we kind of went into volumes as the second step in modeling to provide alternatives. So the AM peak hours from 7 to 8 a.m. and the PM from 4:30 to 5:30. One thing to note is that the northbound vehicles are higher than southbound northbound volumes in the AM, and that's presumably due to commuters heading up either to Philadelphia or to the business parks along US 202 in the counties surrounding Philadelphia. And then in turn, the southbound vehicles, the volumes are the commuters coming back home. One thing we also saw in our fieldwork and in the model was a significant eastbound left turn queue at Malak Street during peak hours, especially during AM peak hours. So we'll take a further look at that. So getting into the existing conditions, this is that queue I'm speaking of. So you can tell here, so this is the Malak Street approach, and then we see this queue is the left turn lane backing up all the way. We see there aren't too many vehicles in the right or through lanes, and that's because this left turn queue basically backs up and blocks them from accessing those lanes. And I said it was bad, and we turn and look the other way, and it's really bad. It goes kind of off the street and loops around. And then this is an apartment, and then there's a proposed development right here, so it's projected to get even worse. So this just speaks to an issue that, there's not much right of way, and there's a clear problem with the utilization of the cross section. Just to give you an idea of the volumes on 202 as well, this is looking north of US 202 during the AM peak, and I said this was the lower southbound volumes, but you can just tell all those vehicles. So, definitely a well-used roadway. Then looking at the ramps, which we kind of identified were problematic areas. This is the northbound ramp first. So one thing to note is that if you're heading north on 202, if you kept going on the two-lane cross section, you would stay on, 202 would turn into US 322 business, and you'd be heading toward the Westchester Borough. In order to actually stay on US 202, you'd be getting off here. It's technically you're getting off, but you're staying on the highway, but it's a one-lane ramp that technically takes you continuously onto 202. And then if you kept going, this is the merge with the High Street northbound traffic as you come toward Malak Street intersection up here. So looking at the southbound ramp now, you can tell here, so we were taking like the crashes earlier. We have an advisory speed of 30 miles an hour, which was routinely exceeded in free flow conditions in our field work. We saw vehicles going an average about 45 miles an hour. No lighting. This is a traffic camera, it's not a light. And then there are raised pavement markers occasionally embedded, and also reflectors in the guardrail. But lane departure could definitely be an issue, especially on the inside here, where there's no rumble strips or anything. And as these vehicles kind of tear around this curve, they come into this merge, which merges fairly quickly with the southbound traffic from the Borough and High Street, which was an issue for us in our alternatives analysis. So looking into the highway performance itself, we used existing, at the time, traffic counts taken in fall of 2018. Our no build was informed by background growth rate, which was based on 2045 long-range forecasts. And then we also added in local developments, but those forecasts already had background development and employment and population taken into account. And then we had 3 final scenarios as build scenarios. We didn't necessarily recommend one of them because they were pretty similar cost-wise and performance-wise. So our deliverable to PennDOT and the county was 3 scenarios. We also had to make some operational and volume adjustments based on local developments and things like that. So at U202 Matlack Street, the 956 Matlack Street development, the developer was doing some things with updated signal timing and also putting in turn lane extensions. We had to build that into our model. At Skiles Boulevard, the further south signalized intersection, PennDOT was doing a redesign of the southbound jug handle and the eastbound approach, so we had to build that as well. And then, of course, this annual background growth, which is informed by the DVRPC regional model, which is separated by county and by functional class. So we've kind of applied that as a blanket in addition to these specific trips generated by local developments. Another thing that we added, I kind of call it like the Jersey factor, is like if anyone's driven in Philadelphia, we're not the most defensive drivers. So as these volumes increase, we would expect people to get more aggressive, especially at merges and near ramps. So we adjusted the driving behavior in VISIM to try and simulate, increased aggression. And then we also used, in addition to the PTV VISIM manual, Wisconsin DOT's VISIM calibration parameters to kind of inform this. But you can tell we adjusted standstill distance, headway time, following variation, maximum deceleration for the vehicle itself and the trailing vehicle, and also the safety distance reduction factor, which did have a pretty noticeable impact on our model, but we felt that was pretty accurate, as Philly drivers are aggressive enough, and you stick them in 2045 traffic, they're going to get even worse, especially near ramps and merges. So LOS, obviously A is what we're shooting for, stable and predictable. Between A and C, D is predictable but approaching unstable, and E and F is unstable and unpredictable. So looking at our intersections here, we have 202 in Matlack is a C, High-End Parkway is a B, and then 202 in Skiles is an A, which deteriorates 202 in Matlack to an F, and 202 in Skiles to a C. In the PM, it goes from a D to an E and an A to a B. So, clear deterioration due to volume there. And then keying in on that eastbound approach, AM existing goes from an E to an F, and then from PM goes from an F to a worse F. And then looking at travel times through this corridor, so it's not a terribly long corridor, but we see them travel times from between existing and no build in the AM double for all of these basically. So if you're heading north or south through the intersection, and then I guess triple in this case for east, if you're taking a left eastbound and heading out of the corridor in the north. PM was a bit less pronounced, so from 3 to 5, 3 to 4, and then northbound and southbound respectively, actually decreasing eastbound left, and this was just due to the PennDOT's signal timing adjustments that were made at the intersection actually helped clear out that queue. So taking a look here now at average speed, we can see the existing AM peak, and it's really an issue of bottlenecks. We can see here we have the lane drop. It goes from 2 to 1 lane obviously at both ramps, so we have clear queuing here and then down here for the northbound approach. This is the kind of zoomed in of the network, and then we see here there's a decent amount of green. It's really only these bottlenecks that are the issue. And obviously 2045 is a worse version of that, but even then, we see, really bad in here. We got a pink and red as vehicles are basically like it's a gridlock or it's almost a standstill at times. The aggressive behavior actually helped, drivers more assertive and actually helped clear out a lot of that northbound queuing. But we see southbound, it's basically just a volume issue. It's a bottleneck. That's what it is. Also, one thing to note is that, the climate around this was, we need to widen this. We need to, this is the only way we're going to be able to accommodate all this volume. And you can see from the average speed and for the model, there's still a lot of green here. It's not like, you need to widen all of 202 to accommodate this. It's really just a matter of addressing these bottlenecks and freeing up flow there. But, there's clearly enough capacity in other sections. It's not like we need to waste money and widen the entire thing. So that kind of informed our alternatives. Looking at the cross sections at the ramp, we obviously have shoulder and gore through here, but there's a decent amount to work with. So our alternative was to squeeze in another lane on the inside. And obviously this merge that I showed you earlier is problematic because we do still have a lane coming from this road here. They kind of loop around and come up. So we have to address that, and we chose to address that by making this approach stop controlled. There are a couple reasons for that, but mainly it's just a volume issue. Vehicles coming north on 202 is about 5 times as many vehicles doing that as the amount of vehicles coming south here and looping around. So stop controlling here, these vehicles have to wait a little bit longer, but for the overall health of US 202, we felt it was necessary. And then looking at the southbound ramp, again, it's, we have gore, we have 12-foot travel lanes along the shoulder and the shoulders, but there's definitely room to work here. So our recommendation was to add an additional lane on the inside, and this is in terms of minimums and radii and curve radius is acceptable within PennDOT's limits. And then the issue becomes just merging down here, and our different alternatives kind of address that. So looking at the cross sections, our second alternative, besides just adding a lane, would kind of be addressing this merging traffic. So to kind of just bend this ramp in and bring it along this southbound traffic and kind of have them taper off and merge in with 202 to kind of give 202 the feeling like it's more of I guess a major roadway, and the high street southbound traffic is kind of secondary to that. So they would have 150 feet of acceleration and then 300 feet of taper. So they would have to, this traffic up here would have to get over by the about this intersection, the Broadway Avenue intersection. And then alternative 3, which PennDOT kind of brought up and we threw in the model just to kind of see, would be actually to put in a traffic signal here and signalize this approach as opposed to having it be free-flowing. This would also mean that all traffic coming from southbound High Street would come up here and either take a right or would have its own phase and be able to take a left and continue south on US 202. And then to address the queuing on eastbound Matlack Street, adding an additional left turn lane just at the intersection, which works because with the additional, the developer putting in protected left turn phasing, we could have both of these lanes go in their protected phase. So then we've gone over the alternatives, and just scenarios here are kind of combinations of the different alternatives. So scenario 1 would be the southbound first alternative, and then we only have one alternative for the northbound and the eastbound left. So obviously the advantage of this is the design is most similar to the existing conditions. There's really nothing downstream we have to do besides address this merge. Obviously the cons is we retain a lot of the issues that came with the existing conditions. So a lot of this southbound High Street traffic is an issue with getting off on Old Wilmington Pike, which is over here. So they basically have to cut across now 2 lanes of southbound traffic to get there, and it does require median reconstruction. Scenario 2 is a little bit better, kind of bowing that that ramp in, kind of that lane in from southbound High Street. It's a kind of a clearer transition from the borough and High Street to southbound US 202. And that traffic has more time because it's kind of merging more smoothly with the 202 traffic. It does require median reconstruction as well. It's a little bit more intense in that you have to kind of adjust this roadway to come flush with the 202 ramp. And then scenario 3 obviously is a safer way because you're getting them a dedicated phase. It does have higher southbound travel time because you're stopping this 202 traffic to let High Street traffic move, and is a bit more intense in terms of construction. All of these have benefits though over the existing. They improve LOS at nearby intersections. They decrease travel times in 2045. They would eliminate bottlenecks at both of the ramps. Additional traffic control and clearer transitions from High Street could improve safety on the highway and in the surrounding area. And the double left turn at Matlack would reduce overall intersection delay and of course on that approach. And kind of something that should be standard, but US 202 already is a major highway and it's set to receive a lot more traffic. So just maintaining a 2-lane cross section is kind of vital just to maintain the viability of that roadway for years to come. So we'll take a look at our VISM outputs. This is still average speed. This is from scenario 1, so we see it's fully green now on southbound. It's really just a bottleneck issue. And then same with northbound as well. We do see the pink and red here, but that's just from that stop control traffic now. But you can tell it doesn't really queue nearly as much as the northbound traffic would. And then here's a ramp comparison just from that interchange. We have the no build on the left and scenario 1 on the right. So you can see it's a lot more free flowing. And scenario 2 is basically the same as scenario 1, just with the bent lane, so we're not going to show that one. But scenario 3 is a little bit different with the signal. So we see here, this is the full network, and obviously it's pretty similar. And looking at the ramps, we do have a little bit slower average speed just because of the signal control, and we do have stop vehicles there from time to time. Northbound is pretty much the same. And then looking at the ramp comparison, again, you can tell it's definitely addresses the northbound and also in the southbound while maintaining safety and prioritizing the High Street southbound traffic from time to time. Taking a look at the LS as well. So we have in the AM no build, we had an F, PM, and an E. So in both AM and PM from scenarios 1, 2, and 3, 202 in Matlack goes up to a D, and 202 in Skiles goes up to a B, just by result of kind of controlling that traffic as it heads southbound. And then taking a look at travel times. So remember our AM basically doubled, our PM increased considerably as well. But in scenarios 1, 2, and 3 for PM, we see it's 3 minutes, 3 minutes, 2 minutes, which is an improvement all across. And that's all I have. So, any questions? No? Thank you.